Hello, good afternoon, everyone. Thanks for coming along to this session. My name is Matthew Prowse. I work for Knauf Insulation, and the session is all about high-performance Rainscreen Façade systems with an emphasis, if you like, on insulation. So if we could see the presentation, please. There we are. So here are my slides. So high-performance Rainscreen Façade systems. There are lots of things to consider when we're designing these systems. You can see a selection of the different systems that we're talking about here, just to start to understand the subject. So, and in each of these, the pictures you can see here, you can see the outer layers and the outer leaf is exactly the same. What's changing is the inner structure. So we've got, from right to left, we've got concrete, we've got masonry, which is can be blockwork or brickwork if it's an existing building. We've got a timber frame wall here and an SFS or light gauge steel frame. So these outer leaves of Rainscreen cladding or ventilated facade cladding, as some people call it, can be applied to all sorts of different walls, and that's one of the considerations that we need to take into account. Here's a system build-up. So in this case, we're showing the concrete, but it really doesn't matter. We're talking about from that inner wall outwards. So what we've got here is a cladding support rail. So this is typically a steel rail that goes on the outside of the building, and that's being used here to hold the cladding up. That in turn is held up by a helping hand bracket. Now those two things are used together to create a ventilated cavity. And the ventilated cavity is extremely important for a Rainscreen system because it allows for any air or moisture that needs to be evacuated from the system to be ventilated away, and it also prevents problems with condensation. We've got the insulation fixings. These are fixing the insulation firmly against the wall, and we'll talk a little bit more about those later on in the presentation. The important bit from our point of view is the Rainscreen insulation. That Rainscreen insulation is our Knauf Rainscreen slab. It's got a lot of really important benefits, which we'll talk about later on in the presentation. Of course, the last item on here is the external cladding. That can be a whole range of different things, from metal to laminates to stone. It depends on the final finish that you want on the building. But everything behind that cladding is pretty typical. So here's some information about the insulation itself. It's robust, and again, we'll talk about that shortly. Dimensionally stable. One of the important things when you think about insulation is do they expand and contract when subject to heat? So if you imagine this is a metal external cladding but on a very high building, the heat that is built up into this cladding system can be really quite significant. So you'd want an insulation product that doesn't expand or contract, and this would be it. It's also weather resistant, and again, we'll touch on that later. It's A1 non-combustible, so that means it doesn't burn. It's in the same category as things like stone or glass or ceramics, that sort of thing. So no smoke, no flame, it just doesn't burn. Thermally, it's very, very thermally efficient, and again, we'll talk about that in a few moments. And it has an acoustic rating of 1.0, which is the best that you can get. So just a little bit of background on Knauf Insulation. This is us in the middle here. We're part of the Knauf Group. You may know other parts of the Knauf Group. So, for example, there's part of the Knauf Group that specialises in gypsum-based products, and another one called Knauf AMF that specialises in ceilings. I work for Knauf Insulation, so we produce non-combustible, low-carbon, low VOC insulation solutions. We make 3 different types, predominantly of mineral wool. So there's glass mineral wool, which is, as it sounds, it's made of glass. Typically, broken bottles and jars and things like that make up the majority of the glass that we use for that. And that's also the case of blown wool. So this blown wool would also be glass mineral wool, but it wouldn't be bound together. It's a loose mineral wool that you would blow into walls and things like that to improve the thermal performance of quite often existing buildings. And there's also rock mineral wool, and we're going to be talking about a selection of rock mineral wool and glass mineral wool products today. One of the things that makes our glass and rock mineral wool particularly special is what we call our ECOSE technology. And we're using the word binder here. For those who don't know, the binder is the glue that holds all of the fibers together. So the basic process is that you melt either the rock or the glass, you spin it into fibers, and those fibers need to be bonded together to make a slab or a roll that has a certain dimension, a thickness or a length or a width. And it's the binder, which is the glue that holds it together. Now, we've got a very unique glue or binder, which has no added formaldehyde or phenols and is 70% less energy intensive to manufacture. So this is part of our commitment to sustainability, and we've got a whole range of presentations all about our sustainability strategy, which is called For a Better World. As I say, we'll touch on those things today, but if you want more information, you want to hear more about For a Better World, those links to the presentations are available on our website. Here we go. So there are 5 principal considerations that we're going to talk about today when we're thinking about the design of facade systems. They are obviously thermally efficient. So wherever there's a building where we have to condition the indoor climate, whether that's conditioning an indoor climate to be cool in a warm environment or warm in a cold area where the weather's cold, you want the walls and the roof and the floors to be thermally efficient, because you're spending energy on keeping that indoor climate comfortable for the residents. So thermally efficient is really important to be able to maintain that indoor environment at a comfortable level without wasting energy. We also need to think about fire, and we need to ensure that it's a fire safe system, which is why we're talking to you about non-combustibility. We want it to be noise reducing. So there are lots and lots of buildings where the residents need a quiet environment, and a noise reducing system is very useful for doing that. We want the thing to be robust, and robustness helps us to build the building, and also for the systems that we choose to last for the lifetime of the building. So robustness is super important, as is sustainability. So we're working to save energy from conditioning the indoor climate. So we should think about choosing products that are in themselves sustainable and have low levels of volatile organic chemicals and low levels of embodied energy. So what we're going to do, we're going to start with fire safety, because this is a real hot topic all over the world at the moment, following some high profile tragedies and building fires. The reaction to fire classifications that I'm most familiar with are the European standards, and you can see that there are a whole bunch. There's about 40 different classifications. They're split down into A, B, C, D, E, and F. F is sort of effectively the worst classification, and A1 means non-combustible. But in between, there are a whole bunch of different ones. And the reason for this is because they're classified with an S. Now, S stands for smoke. So there are various levels of smoke that are released from combustible products when they burn. And these are classified as 1, 2, or 3. There's also a classification for D, which is for droplets. So that will be flaming droplets. So where a product burns and releases flaming droplets, you can have classifications of 0 or 1 or 2. So when you combine all these different elements together, you can end up with 40 different classifications, which is can be really confusing. Now, again, we've got a whole CPD, an hour to talk all about this, which is available should you wish to book it. But just to give you a sort of a visualization of what a fire looks like in relation to an insulation product, we've borrowed some videos here from an organisation called Fire Safe Europe, which I really hope are going to work, which they don't appear to be at the moment, which is a bit of a shame. Seems to be having a technical glitch. That's partly irritating. Here we are, finally. Okay, so what you would have seen had the first video worked would be a fire against an A1 non-combustible product. And as you'd expect, it doesn't burn, it doesn't smoke, and it doesn't flame. Now we're going to try and play a video of a product that is classified as a B. And as I say, this is borrowed from a company called Fire Safe Europe, and it's intended to give you a visual representation of what a fire looks like. So you can see a room here that is lined with an insulation product that is classification BS1D0. Now we've sped this up a little bit. You'll see the ticker in the bottom corner there moving quite quickly now, and it'll slow down again into real time after a few minutes. So in the corner of this room, there's a gas burner. The gas burner releases some amount of heat that's intended to represent something like a chair or a bin that's gone on fire. And you can see here now that the insulation product has reached flashover. So it's now burning of its own accord, and it's releasing heat irrespective of the heat that's been added by the gas burner. You can also see the smoke coming out of the door at the top there, and the fireman waiting to put the fire out. So this is the result of that amount of heat being applied to this product, and this is what's happened after 11 minutes and 38 seconds. So let's see if the next video play. The next video is of a product that has got a classification of E. So that's a more combustible product than the last one that we've seen. Just waiting for the little blue circle to stop going around. Here we are. Bit of a spoiler there as to what's going to happen. So let's play this video and look at what a product looks like if it's got a fire rating of E. So again, you can see the gas burner in the corner being set off. This video isn't speeded up. So you can see there are burning droplets being emitted, and quite a large amount of smoke after only 30 seconds. So irrespective of any video glitches that we've got at the moment, hopefully that allows you to visualize the effect of the choice of insulation materials that you might make. Let's say if you want to see these without the glitches, head over to YouTube, where they're available on the Fire Safe Europe YouTube channel. So here are the different sorts of materials that are typically attributable to these different fire classifications. So over here is A1 on the left, A1 glass and rock mineral wool insulations. PIR, PUR and phenolic rigid insulations tend to be anywhere between a B and an E, and polystyrene, XPS and EPS insulations tend to be an E or an F. Oh, great, another video. Let's see how we get on with this one. What we're trying to show with this animation is the effect of fire spreading on the outside of the building. And this is basically what we don't want to see in a real building. So there will be a fire in a ground floor room that breaks out through the window. This is a good reason as to why you might want to pick a non-combustible insulation product. And it's also important to use cavity barriers. So cavity barriers will prevent the spread of flame along the outside of the building. And here we are, will prevent, or rather, sorry, not prevent, they will slow down the spread of fire on the outside of the building. They should be designed to give you at least 30 minutes between one floor and the next. I'm so glad that I picked so many animations in this presentation today. So there you go. You can see the fire breaking out of the window and very quickly moving up to the outside of the building. This would be what would happen if the fire was completely unencumbered by any fire barriers. So what you would require is for the fire barrier to do its job and to prevent the fire, or reduce the speed at which the fire moves from one compartment to another. So if this is a floor level here, these horizontal cavity barriers are at floor level, and then again at the floor above in a multi-story building, they're also fitted around the windows. So that when the fire breaks out of the window, which will often happen in the case of a fire, that it doesn't move up the outside of the building quite so quickly. So working together, the cavity barriers and the non-combustible insulation can make the building a lot safer than it otherwise might have been. We also insist that the insulation is fixed to the wall with metal washers. Metal washers are non-combustible, and they'll make sure that the insulation stays fixed to the building, so it doesn't fall forwards towards the to the back of the cladding, and it also enables helps the cavity barriers to do their job. So our one takeaway from that section would be to specify non-combustible products wherever you can. As I say, there are CPDs available, and there are Knauf insulation employees available to talk to you about this in more detail. So the next consideration is thermal efficiency. As I say, keeping the indoor climate the way that you want it. Now, the requirements for U values are evolving, and that's happening all over the world. And that is a general international push towards saving the energy that we use to condition our indoor climates. Now, trying to calculate and work out what the impact of a particular system will be onto a building is quite complex, because as we can see up in the diagram here, there's a whole range of different products with a whole range of different thermal conductivities. So we've got insulation, we've got metal, we've got different board materials, and let's have a look and see how they compare. So on the scale on the left-hand side here, we've got the thermal conductivity in watts per meter Kelvin. So these are the insulation products that are over here, and their thermal conductivity is very low, 0.035 and 0.034. So that's a very, very low thermal conductivity. They don't conduct a lot of heat, as you might expect from an insulation product. Now, if we change the scale on the left-hand side and now compare it to the board materials, you can see the board materials have a much, much higher thermal conductivity. This scale has gone up by a factor of 9 or 10. So now the impact, the thermal impact of the insulation is down here, and the plasterboard and the sheathing board are up here. But those aren't the biggest problem. The biggest problem would be the metal components. Obviously, things are made out of metal that are designed to conduct heat, but as well designed to be load-bearing in buildings. So steel over here and aluminium, with aluminium, we're talking sort of a factor of 5,000 times more heat being conducted through the aluminium than through the insulation. Now, what the effect of that is, it makes it incredibly difficult to calculate and predict the impact of these metal rails and brackets that are throughout the structure. The way that you do that is by using quite a complex program that can model it in 3 dimensions and predict the heat loss. And then that's presented in a U-value calculation. Now, unfortunately, most of the U-value calculations are very, very impenetrable. They're very difficult to understand whether or not the correct materials and the correct types of products have been taken account of in the calculation. So what we tried to do is to be a little bit more transparent. So you can see here is one of our U-value calculations. We've got the diagrams of all the different layers going through the walls. We've got the different heat flows from the thermal model, and also all the dimensions of the metal components, which are really critical to being able to understand whether that is an accurate U-value calculation, whether that really reflects the intended design of the building. So we would suggest you insist on a calculation that really sets that out and makes it clear for you. We'd also suggest that the stud work in here, where it's applicable, is fully filled with insulation, because that's a zone that's often not insulated, and that helps enormously with the U-value. And again, please do contact us to find out some more information. So let's talk about noise reduction. There are lots of buildings where it's beneficial to reduce the amount of noise that is experienced by the users of the building. So over in the top corner here, we've got a hospital where people are being treated for illnesses, obviously, and recuperating and recovering from illness is made much more difficult in a noisy environment. We've also got a university here, so there are young people trying to learn and study in this university, and a noisy environment wouldn't help them to do that. We've also got some student accommodation here, so you've got people sleeping in this building, and this would apply to flats or apartments or any building where you've got a number of different people trying to sleep and get some rest. In this particular case, these are students, so these guys need to be bright and up and about when they go to the university the next day. So keeping a quiet environment for them is great. There are also work environments where noise reduction is important. So you can see here, this is an airport, and this is the air traffic control tower. So I use this airport quite a bit, or I used to, and I'm much more comfortable if the guys who are directing the planes have got a comfortable environment to work in that's not too noisy. So how do we achieve good acoustics? Well, here's a matrix here. It's a mass absorption matrix. So there are 2 aspects to this that we really need to think about. One is the mass of the building. So that would be sort of concrete or masonry or something like that. Things with high mass are inherently inherently perform really well acoustically, but that's not always possible. So there are often buildings that are made from very lightweight structures, and in those cases we want to fill those lightweight structures with as much absorbative material as we can, or materials that absorb the sound. So down in the bottom corner here, we've got a lightweight structure, low mass, but also low absorption, and that's only getting one out of 5, 1 star. If we increase the mass, so if we got this scale here and increase the mass, it gets better, but it's still not as good as it can be. Down here, we've got a structure which is a low mass structure, but it is filled with absorbent material. And in terms of its acoustic performance, we're giving that a 4 out of 5. The best possible solution is to combine the mass and the absorption, and that gives you the best possible acoustic performance. So that will be the options there. So certainly move towards the right-hand side of this chart here if you want good acoustic performance. So another animation, great. This is going to show the science behind how mineral wool actually works in terms of absorbing sound. So the sound energy will enter into the matrix of fibers, and it'll bounce around effectively on those fibers, and it'll be turned from sound energy into heat energy. So what we're actually doing, it's a very small amount of heat energy, but what it does, it serves to dissipate that sound energy so that it isn't troubling the people who are using the building. And I wonder if this one's going to work. Oh, here we go. We're getting something. Hey. So as I say, here's the matrix of fibers. This would be under a microscope potentially. And you've got the sound waves here being represented by the blue arrows. And you can see that very few of the blue arrows make their way through to the other side of the mineral wool. That's because they're being trapped and turned into a different kind of energy within that matrix of fibers. So in terms of sound insulation performance, we've got some example build-ups here, and they tell us how the insulation performs. So this is a cut through of the kind of light steel frame and rain screen systems that we were looking at earlier. So in this case, it's just a 100 mil SFS steel framing system with 100 fully filled with mineral wool. There's nothing here in the cavity whatsoever, and that achieves a thermal performance of 48 decibels. Now, when we move to the putting insulation in the cavity, the thermal performance, the acoustic performance jumps up massively. So that is improved by 7 dB. Now, each 3 decibel improvement is a halving of the acoustic energy. So that is a really excellent performance just by putting 1 extra layer of mineral wool in the wall. We can improve that further still by increasing the depth of the insulation, first of all on the inner leaf and then on the outer leaf. So you can see see the effect that these improvements are having, and the thickening of insulation will significantly improve the acoustic performance of the wall. So here's a cutaway of a wall, and there is a potential for sound to pass through that wall. So somebody's made a real big effort to fill the party wall between 2 apartments with mineral wool, and they've also filled the cavity here as well. And the same on this, which is a masonry wall. We can produce acoustic simulations. So if this is something that you're interested in, please contact your local Knauf insulation representative. So what we'd like to take away from this is use absorption and contact us. The next topic is robustness. So we want the product to be really robust. Now I'm aware that where I live is slightly wetter and damper than where many of you are watching from, but the important thing to take note of here is that the insulation product that we're talking about is produced using a water repellent additive. And so during the construction phase, if there is rain or heat or cooling or freezing and thawing or anything like that going on, this product is robust enough to handle it and has been tested to do so. There's also, we've also undertaken wind loading tests. So a typical Category 5 hurricane, the winds will travel at around 70 meters per second. And in the laboratory test that we undertook, the Rainscreen slab, when properly fixed, will resist a negative wind pressure of up to 76 meters a second. So it's important that the product is robust in order that it does its job and lasts for the lifetime of the building. So considering the weather conditions while construction is going ahead, whether that be hot or cold, whether it be dry or wet, is really important. But in any case, specifying robust materials is always the best policy in our opinion. So moving on to the last section now, sustainability. Again, as I say, we've got a whole range of presentations about sustainability, and this is just a little taster, if you like, of this particular aspect of the insulation product. So what we've done is we've calculated and measured the embodied carbon of our products in order to try and reduce them. I mentioned earlier on we have a sustainability strategy called For a Better World. That's our sustainability strategy that we're using and we're following for the next 5 years. And one of the pillars of that is to reduce the embodied carbon in our products. So reduce the impact on the environment of the manufacture and transport of these products. What we consistently find is that the Knauf insulation products are lower in terms of embodied carbon in comparison to competitors' products. So here are some examples of some different Rainscreen systems, and you can see in every case that our embodied carbon is lower than our nearest competitor. All of the information about the embodied carbon of the products is available from our website. We publish all the information and make it publicly available. So please do go ahead and take a look. Again, we mentioned in the ECOSE technology, since there's it's a proportion of our product, it's one of the areas where we can improve the embodied energy. And this particular product is roughly about 70% less energy intensive to manufacture. So that's a big win for us in terms of our embodied carbon, amongst other things. It also enables us to claim a Eurofins Gold award. Now, Eurofins Gold is a measure of the amount of volatile organic chemicals, or VOCs, that are emitted from products. And we've managed to get the gold standard, which is a very high standard. And you can see here that these VOCs are not being emitted from the insulation products in a typical Rainscreen type wall. So they are not releasing those volatile organic chemicals into the atmosphere, and meaning that that our residents have to breathe them in. So in summary on sustainability, we suggest you choose a product with low embodied carbon. Again, CPDs or presentations, in other words, are available, and we'd encourage you to get in contact with us and ask us questions and talk a little bit more about it. So we've got a few minutes before the end of this slot, and I think I'd be open to answering. So, sorry,
I was on mute. A common digital error. I'm just going to go to the chat box here. There seem to be some questions. It's are the structural members sound bridges? Example, the posts, rails, etc.
Absolutely, they are. Yeah, yeah. They we mentioned how they were thermal bridges. Effectively, they're transmitting heat, but they would also transfer sound, which is another reason why you need products pack in the system that will offset the sound that they're pumping out.
Okay, and then another thing that was said is it's interesting that your products have thermal, fire, acoustic, sustainable, moisture resistance. How readily are they available in South Africa?
Yeah, they're readily available in South Africa. I'd be very happy to put you in touch with the guys that you need to speak to discuss the availability and other aspects of the products. Very happy to do that. If you were to send me a little message and contact me on this in this forum, I'll put you in touch with those guys.
Okay, Matthew, if you just give me a second, what we're going to do is I'm going to put your email address in the chat box so that if anybody has any questions, they can give you a shout. If you just bear with me a second. Okay. Are there any further questions, anybody? Okay, I see there is one coming through. Let's see. Most of your slides show different construction methods that I'm used to. Does the values provided differ according to the type of construction?
Absolutely, it does. Yeah, yeah. This is why we offer the. I assume we're talking about thermal values here, so I'll talk about thermal values first. What we offer is calculations that are bespoke to any particular product, any particular project, rather. So if we can get the details of the particular project, we can make calculations that are specific to that project, but they absolutely do. There are examples of different constructions as well on our websites. So, for example, an insulation, a wall that has timber framing full of insulation and then some of the Rainscreen slab on the outside would be a much better performing wall than something like a concrete wall with the same thickness of insulation on the outside. But as I say, the thing to do is contact us and we'll make some calculations and predictions based on a specific project. And we have the technical services to do that.
Okay, fantastic. I'm just going to wait just for a minute more, just in case we get another question, Matthew.
Yeah, no worries. I've finished slightly early just in case there was an avalanche of questions.
No worries, no worries. So everybody, if you've got any last questions for Matthew, please do post them in the chat box and we'll get them to Matthew.
And I'll just quietly have a little drink while I'm waiting.
No, perfect. Shame, you've done a lot of talking now.
Oh yes.
You need a break. Zara, are there any more questions on the chat? Okay, there doesn't look like there's any more questions, Matthew. So with that, I'm going to say thank you very, very much for your presentation. It was certainly enlightening and very interesting. I'd like to thank all our attendees for joining our session. our CPD accreditation, please just a reminder that you need to register in the link provided in the chat box. If you've done it once, don't worry about doing it again. We will CPD accredit you for each one that you have been in attendance for. And with that, we say thank you, Matthew, and goodbye.
Thank you. Thanks for inviting me. Thanks.